All right, today we're going to talk about right triangle trigonometry. So, we've all heard of the phrase so ka toa in our geometry or math 2 courses. So, what does that mean? So, this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, and we're going to use these throughout this lesson to figure out how to solve missing angles or missing sides. So in the first example, find the size of angle A. So that is this angle right here, and of this triangle, and we know that it's a 90-degree triangle. So I'm just going to pick things at random here. I'm going to say that here's our opposite side, and here's our adjacent side. And so I could pick any three sides to find the angle here. So we've got our adjacent and our opposite side. So if I'm going to use adjacent and opposite, then from these choices here I'm going to use tangent. So I'm going to say tangent, and I don't know what this angle is, I'm going to call it theta. Tangent theta equals opposite over adjacent, so 3 over 4. And now I'm trying to figure out the angle. So in order to figure out the angle, I have to do inverse tangent. So tangent, we do inverse by writing a little -1 here, 3 divided by 4. And that's going to give us our angle. Now to do this on the calculator, you have to, you're going to hit the second button, and then tangent, and then 3 divided by 4, and then you're going to press enter. You may want to write these calculator steps onto your paper. Okay, so let's do it. Second tan, 3 divided by 4, enter, and then I get 36.86. So I can say the angle A is approximately 36.9 degrees. If they don't tell you about rounding, you should do it to 3 significant figures. SF stands for significant figures. All right, next. Show here that there's a right triangle here where FH is 14, and this angle here is 52. We've got a right triangle. Find the length of side GH. So we're trying to figure out this side right here. So this side here is touching the angle, so it's adjacent to angle H. Okay, and this one here is across from the 90-degree angle, so this is the hypotenuse. And so if I'm dealing with adjacent and hypotenuse, I'm going to use cosine. So let's write this out. So we've got cosine 52 equals adjacent over hypotenuse. I'm just going to call that x there. So we've got x over 14 because cosine is adjacent over hypotenuse. And so for solving for x, one thing that we could do is I could say, okay, well, I could put this over 1, and I can cross multiply, and then I would have 1 times x, I'm just going to call that x, equals 14 times cosine 52. Okay, so let's type this into the calculator. 14, let's hold this like this, 14 times cosine 52. Enter. And then I get 8.6, we'll round that to 8.62. And what are the units? Centimeters. Okay. All right, next question. Let's do the next page here. Okay, Emma's standing in front of a big tree. She measures the distance between the tree as 15 meters from A to B. So let's label this as 15 meters. And she also measures that the angle at A is 40. Okay, so we know that angle is 40. Okay, find the length of BC. Okay, so BC is this part right here, so I'm going to call that X. Here, I'll just make it out here so you can see it. So this height is X. So we've got the opposite and the adjacent side. So we've got our opposite side and we've got our adjacent side. Okay, so if I'm dealing with opposite and adjacent, we go back to our trig formulas, and opposite and adjacent means we're going to use tangent. So I'm going to write this as tangent 40 equals opposite over adjacent, so X over 15. And like we did on the earlier example, I could put this over 1 and cross multiply, so 1 times X equals 15 times tangent 40. And let's type that into the calculator. 15 times tangent and 40, and I hit enter, and we get 12.586. So 3 significant figures, that is 12.6. And this is meters from here. Okay. Next question. Determine the length of the unknown sides of each right triangle. Okay, so we've got this angle here. So let's solve for y first. So here is the opposite. And we've got our hypotenuse. So what is our acronym? TOA. So opposite and hypotenuse means we're going to use sine. So I'm going to say we've got sine of 61.2 equals y over 9. Okay, so if I put this over 1 and we cross multiply, then we get y equals 9 times sine 61.2. And so let's type that into the calculator. 9 times sine 61.2, and then I get 7.886, so that's going to be 7.89. Okay, now let's find z. Okay, so here we've got the adjacent. So if we use adjacent and hypotenuse, then we're going to use cosine. So I'm going to say cosine 61.2 equals adjacent over hypotenuse, so z over 9. And then if we put this over 1 and cross multiply, then we can say z equals 9 times cosine 61.2. Let's type that into the calculator. 9 times cosine 61.2, and I get 4.34. So z equals 4.34 centimeters. Okay, let's do the next one here. We've got opposite and hypotenuse. So opposite and hypotenuse, we're going to use cosine. So I can say cosine 34 equals 10.2 over z. Now, if I put this over 1 and cross multiply, we're going to get z times cosine 34 equals 1 times 10.2. And then to solve for z, I have to divide both sides by cosine 34, and then I get z equals 10.2 divided by cosine 34. And I need to put that into the calculator. So I go 10.2 divided by cosine 34, and I hit enter, and I get 12.3. There's no units. Okay. All right. So now let's find x. X is adjacent. So I could do sine, cosine, or tangent. Let's do, if we're trying to find adjacent, let's do tangent. We don't have to, but I'm going to use tangent. Now that I know the hypotenuse, I could do sine, but let's just do tangent. So tangent of 34 equals opposite over adjacent. So 10.2 over x. 10.2 opposite over adjacent. 10.2 over x. So we need to solve for x. I'm going to put this over 1. We can cross multiply. I get x times tangent 34 equals 1 times 10.2. Okay, we're solving for x, so we have to divide both sides by tangent 34. I get x equals 10.2 divided by tangent 34. Okay, let's type that into our calculator. 10.2 divided by tangent 34, and I get 15.1. Question B might not be correct. I have a different answer in my answer key, so I'll have to come back to check this one here. Okay, so we've got this angle here. Let's solve for x first. We've got opposite, it's far away, and we've got the adjacent, which is x. So opposite and adjacent, we're going to use tangent. So I'm going to say tangent 66.4 equals opposite over adjacent, so 21.3 divided by x. And so we can put this over 1 and cross multiply. We get x times tangent 66.4 equals 1 times 21.3, right? And then to solve for x, I divide both sides by tangent 66.4. I get 21.3 divided by tangent 66.4. And let's put it in the calculator. 0.3 divided by tangent 66.4, and I get 9.31. Alright, so now let's solve for y. Y is the hypotenuse. So if I've got the hypotenuse, we can use sine or cosine, depending on what we want to use. But we've got the opposite here. Let's just go with that. So I'm going to use, if I go use opposite and hypotenuse, I'm going to use sine. Okay, so I'm going to say sine of 66.4 equals opposite over hypotenuse, 21.3 divided by y. Okay, just like before, we put this over 1. We can cross multiply. We get y times sine 66.4 equals 1 times 21.3. Divide both sides by sine 66.4. We get y equals 21.3 divided by sine 66.4. And let's do that in the calculator. 21.3 divided by sine 66.4. And I get 23.2. Okay. Alright, let's do the last one. So you got a ladder that's 8.3 meters long. Okay, 8.5 meters long. Okay, and it's leaning against the wall, so that LKM is 30 degrees, and KLM is a right triangle. So this is a right triangle. Okay, so you need this distance here, because that's our ladder, and there's our 30-degree angle. Find the distance of KL. Okay, so this is adjacent right here, and we're going to call that X. Okay, and we know the hypotenuse. So if I've got hypotenuse and adjacent, then we're going to use cosine, aren't we? So I'm going to say cosine 30 equals opposite over adjacent, so x over 8.5. And so we solve for x, so I'm going to put this over 1, and we can say 1 times x equals 8.5 times cosine 30. Okay, let's get our answer. 8.5 times cosine 30, and I get 7.36. And this is in meters. So that's the answer for part A. Okay, B, find how far up the wall the ladder reaches. So for question B, we want to find how high up the wall reaches. So since I called that X, I'm going to call this Y. So we're trying to find Y. Okay, so if we're trying to find Y, I'm going to use opposite of the angle and the hypotenuse. So if I'm using opposite and hypotenuse, I'm going to use sine. So I can say sine of 30 equals opposite over hypotenuse, y over 8.5 meters. Okay, so we can put this over 1 and cross multiply, and then I get 1 times y equals 8.5 times sine 30. 1 times y equals 8.5 times sine 30. So let's put that into our calculator. 8.5 times sine 30, and then I get 4.25 meters. Okay, now let's do question C. The instructions for use of the ladder state that it should not lean against the wall at more than 55 degrees. Find the maximum height on the wall that the ladder can reach. Okay, so it's not going to lean more than 55 degrees. So let's pretend that we've moved the ladder, and now it's at 55 degrees. Okay, and the ladder is still 8.5 meters, right? Okay, this is question C, right? So our ladder is still the same height. The angle has gotten bigger, and so we're trying to figure out, find the maximum height on the wall. So that's this distance here. So let's call this Z. Okay, so we've got opposite and the hypotenuse. So I'm going to use sine, which is sine 55 equals opposite, which is Z, over hypotenuse, which is 8.5. And then I could put this over 1 and cross multiply. I get 1 times Z equals 8.5 times sine 55. And then I can put that into the calculator. And so I go 8.5 times sine 55, and I get 6.96. So that is how high, the maximum height you're going to climb up the wall. Alright, the next part will be done in the second video.